order of liquids, digestible solids, fats, and then non-digestible solids. And here I have written down the liquids, digestible solids, and fats, and what their timing depends on. So in liquids, the emptying time depends on tonicity. So in tonicity, we mean that one is isotonic to plasma will empty faster compared to sugary drinks, or maybe if you drink pickle juice, that's a really salty drink. So that it will change in whether it's hypertonic, hypotonic. Also the pH. The lower the pH, the slower the emptying. Also, the amino acid L-tryptophan seems to slow emptying, and we also have when we have fats, oils that slows emptying, and usually the 12 to 14 chain medium length carbon chains and fats. I have gravity here with a cross over it because that has minimal effect, contrary to what we have been maybe taught by our moms or just in general. Usually we're told that to always sit up after we eat or it will not get digested, but actually you can lie down and eat. It wouldn't have an effect on gastric emptying. Then we have the digestible solids, which rely on the particle size. So the larger the particle size of the food, the slower the emptying. So an example of this is brown rice versus white rice. Brown rice has a slower emptying rate than white rice, which is why there's more satiation. The size of the food needs to be 1 millimeters in diameter before passing to the small intestine. And the foods that are smaller than a 1/4 millimeter pass right through the small intestine. But the larger particles have a lag phase before emptying, and that's when crushing and retropulsion comes into play until we get to that 1 millimeter in size diameter. And then the antrum and pylorus have a size sieve going on. It's a fluid dynamic where I have drawn here. So I've shown that the smaller particles here in red are mostly here at the widest aperture of the pyloric sphincter. And then the larger particles move toward the walls and the sides until we have more crushing and retropulsion until these get as small as these. Then we have the fats. So it's slower emptying than liquid because the density differences, and also fats form globules. If you look at water and fat on top of it, you see that they form these globules, these little balls of fat where they're not letting water come through. And then also lipid digestion in duodenum slows emptying. Then we have the non-digestible solids where the particle size are 3 to 7 millimeters, and they're non-nutritive to us humans, but bacteria want these, and they exit the stomach during a phase 3 of migrating motor contractions. And the example of this are corns that we eat. Sometimes we don't chew it because they're slippery and we don't get to chew every little piece of it. They don't get broken down as much through our stomach, and so that would be non-digestible for us. Then we also have some disorders of emptying. We've already talked about 2 of these, the scleroderma and Chagas disease, which was the lack of musculature. So we will have problems with gastric motility with these two diseases. And then we have the gastroparesis, where stomach emptying is too slow, and usually these patients get feeding tubes. People who get these are type 1 diabetics because of neuropathy. They don't have the same motility as other patients that don't have type 1. And also, some patients tend to get this after surgery. It occurs idiopathically, so it is unknown. Another disorder we have is rapid emptying, which happens in patients who've gotten a vagotomy, where they have pancreatic exocrine insufficiency. So they have poor fat breakdown, where pancreatic exocrines would normally inhibit emptying. They don't have these, so it's hard to break down foods. And it just goes right through. And then there's the dumping syndrome. Usually happens after gastric bypass and stomach reduction. It's 10 minutes to 3 hours after eating large or sugary meals. These patients tend to get diarrhea and cramping, and it hurts really bad. So if these patients have gotten gastric bypass, they need to know certain foods not to eat and to eat. Also, some stranger ones we have are retained materials. There's this thing called the bezoar, which stay in the stomach. It's like plant materials, hair, or medication that don't go through the stomach. They just stay in there. It can be made of anything, really, anything that doesn't go through, and they become concentrated. These patients are asymptomatic patients, and this happens very rarely. And to treat this is with physical extraction, enzymatic breakdown by drinking enzyme solution, or mechanical disruption, which is just shoving it out. Also, we do get foreign objects into when there are patients who have eaten, or kids who eat foreign objects, or if you eat like magnets. If you eat one magnet is fine, but when you have two magnets, that can cause a problem, and that needs to be removed as fast as possible.